So this is the answer key with the problems worked out for worksheet 7 for properties of similar triangles. The actual PDF answer key is in the folder, but if you need more verbal explanation in real time solving, this is the place to look. So in the first problem, we have a triangle that has a line that's parallel to one of its sides, and that line intersects the other two sides of the triangle. And then the hint is to use the triangle proportionality theorem to find this length from P to N. So we got to think about, and hopefully in your notes you have this, what does the triangle proportionality theorem say? It says that if I have a line that's parallel to one of the sides of the triangle and it intersects the other two sides, and here we intersect at P and Q, then that line breaks the other sides up into proportional pieces. And so we can use that to find the length Pn. So I'm going to just kind of shade these in a little bit so that we can see this length, this 3 to the length Pn, is going to be the same as the length MQ is to this length 5. And so we can set that up. I'm going to say, it doesn't matter if you do 3 over Pn or Pn over 3. So I'm not going to use a variable x for Pn. I'm just going to leave it as Pn. So Pn, that's the distance from P to N. I'm going to say P to N divided by 3. And that's going to be the same ratio as if I take 5 and compare that to 2. We could go the other way around as well. And so now I'm just going to solve this. So I'm going to cross multiply in this proportion. And so I have Pn is going to be equal to 15 divided by 2. That means Pn is equal to 7.5. And that's our solution. So in the second problem, we're going to use the converse of the triangle proportionality theorem. And so the converse is this, that I can show that these two line segments are parallel lines if I can show that they split this triangle up into proportional parts. So what I need to know is I need to know that this to this is going to be the same as this length to this length. So the ratio of DC to AD is going to be the same ratio as EC to BE. So of course that means I need to know what AD is and what BE is. And I can figure that out because I know over here it tells me that AC is 36 centimeters. So if this is 36 and DC is 20, then 36 minus 20, that gives me 16. So AD is 16. And then similarly, I can calculate the length BE because BC is 27, and 27 minus 15 is going to give me 12. So I just need to show that these ratios are going to be the same. And again, I can do, it doesn't matter if I go 16 over 20 or 20 over 16, as long as I do the same thing in the same way for the other side. So I'm going to do 16 over 20. And I don't know that they're equal yet, so I'm going to put a question mark over the equal sign. It's 16 over 20, and I have to show that that's the same as 12 over 15. So let's go ahead and reduce. 4 goes into 16 4 times, 4 goes into 20 5 times. And when I look at 12 over 15, the common factor is 3. 3 goes into 12 4 times, and 3 goes into 15 5 times. And because I get the same proportion here, I can get rid of my question mark. Now I know they're equal. And because they're equal, I can say, therefore, DE has to be parallel to AB by the converse of the triangle proportionality theorem. So I can put a little arrow on here to show that those lines are parallel. So there's a corollary to that theorem. It's called the two transversal theorem. And if I look here, you can see in this picture that these trees make transversals to these the sides of this looks like multiple triangles, right? So we have 1, 2, 3, 4 trees there. And what it says is that if three or more parallel lines intersect two transversals, so here we have the transversals coming here and intersecting these parallel lines, that they divide the transversals proportionately. That means that, for example, if I have this length AB to BC, it's going to be the same as this length KL to LM. And I can just keep going like that. I can say BC to CD is going to be the same as LM to MN. So they're going to be proportional all the way down. And here we have 4. It says 3 or more, so we could have 100 of them, and it would be the same. So it doesn't matter how many there are. So let's start with the first setup. I want to find the length LM. So here is LM right here, and so I'm going to use the ratio. I'm going to say AB to BC is going to be the same as KL to LM. And then I know AB, I know BC, I know KL, I don't know LM. So I should be able to calculate it out. So I'm going to say 2.4 to 1.4 is going to be the same as 2.6 to LM. And now I can calculate that. So I'm not going to calculate that right this second, but that's my setup. So let's do the other one. Now I need to know MN. Well, to do MN, I'm going to also set this up, and I'm going to say, okay, 1.4, so if I take BC to CD, so 1.4 to 2.2 is going to be the same as this LM to MN. So now you see here, there's two things I don't know. But look over here, I'm going to figure LM out, and then I can put that answer right here. So let's go ahead and figure out the one that we did in red. So I need to take and cross multiply and solve. So I have 2.4 times LM, whatever that length is going to be 1.4 times 2.6. And then I'm going to divide by 2.4. So LM is going to be 1.4 times 2.6 divided by 2.4. Now we're going to get a decimal number, and it says to the nearest tenth. And the number I got was 1.5166666 repeating. So to the nearest tenth, that's going to be 1.5. So that's my approximation. So this was 6 repeating, right? And of course we're doing centimeters on this because it's a picture. All right, so now I know that LM is 1.5 centimeters, so that's what I'm going to use here. I'm going to use 1.5. And so we're going to cross multiply again. Maybe I'll use a green pen here. And so I'm going to have 1.4 MN is going to be equal to 2.2 times 1.5. And then I need to divide by 1.4. Divide by 1.4. And so we'll go up here. MN is going to be 2.2 divided by 1, or 2.2 times 1.5 divided by 1.4. And again, we're going to round to the nearest tenth. And when we do that, I get a value of 2.357. So we'll round that to 2.4. So that was not. Let's see if we can write that better. So MN equals 2.4 centimeters. So the last problem, number 4, is the triangle angle bisector theorem. That's what we're going to use. And this theorem says that if I have a triangle, ABC, and I bisect one of the angles with a ray, that when that ray hits the other side, that it splits that segment into a proportion or into a ratio that's the same as the ratio of the other two sides of the triangle. So that's kind of cool. So I'm gonna highlight these just to help us identify. So those two sides are going to make a fraction, a ratio that's the same as these two pieces that it cuts on the third side. So let's go ahead and set that up. So I'm going to, again, I have a choice. I can do 8 over y minus 2 or y minus 2 over 8. Doesn't matter. But if I do 8 over y minus 2, then I have to do 4.5 over y divided by 2. And if I went the other way, y minus 2 over 8, then I'd have to do y divided by 2 over 4.5. So let's go ahead and do this. And I'm gonna do 8 divided by y minus 2. So that means when I set this up, I have to start with 4.5. So 4.5 divided by y divided by 2. Now, it may bother you that there's that y divided by 2 on the bottom of that fraction. We don't often see that, but don't let it worry you, because when we cross multiply, it's not going to be on the bottom anyway. So we're going to cross multiply this, and so now I'm going to have 8 times y divided by 2. Looks better already. And then I'm going to have 4.5, but remember I'm multiplying this by y minus 2, so I need parentheses here, y minus 2. And I'm going to distribute this. So we got to be careful when we distribute. We got to multiply twice. So I'm going to have 4.5y. And then when I double 4.5, I get 9. So this is minus 9. And on the other side, I just have 8 times y divided by 2. So it doesn't matter if I divide first or multiply second. I always encourage dividing first because you end up with a smaller number. 8 divided by 2 is 4, and then we have 4y. So we have 4y on this side. Now I just have to rearrange things so that I can solve it. So I want all the y's on one side and the numbers on the other. So I'm just going to move the 4y over here by subtracting it from both sides. And then I'm going to move the minus 9 to the other side by adding it to both sides. So I'm not showing those steps because you know how to do that. So I'm going to have 4.5y subtract 4y. And so this is going to be 0.5y that's left on this side. On the other side, I took the minus 9 and added 9 to both sides. So on the other side, I have 9. So what I have to do is I have to divide by 0.5 on both sides. Okay. So if I was dividing by 1, if I divided 9 by 1, I would have 9. But I'm only dividing by half, so that half is going to go in there twice as much. So if you take 9 divided by a half, you're going to get 18. So I'm going to have 18. Okay, so this is going to be y equals 18. Now, y equals 18 is not my answer because it asks me to find the length AC and the length DC. So y equals 18 is a step on my way. Now I have to plug it in. So 18 divided by 2 means that this segment DC is going to be 9. And 18 minus 2 means that this segment AC is going to be a length 16. And then I'm done. Now, a word about these theorems. I don't expect you to have them in your memory. I expect you to be familiar with them and be able to use them. And so they're in your notes. And so make sure that you have them so that you can look them up when you need them.